Welcome to the Deep Dive. Today we're looking at the winter 2025-2026 forecast. And there's a lot pointing towards what we're calling a potential cold surprise. It's a really complex setup this year. So if you're looking beyond just the standard seasonal outlooks, this is definitely the deep dive for you.
Yeah, absolutely. We really have to look beyond the tropics this season. The baseline is pretty straightforward, though. NOAA has confirmed we're in a weak La Niña. The oceanic Niño index, the ONI, it's running about minus zero point 0.5 degrees Celsius, and that weak cooling expected to stick around right through the core winter months.
Right, okay. And this is where it gets interesting, isn't it? Because a weak La Niña, it doesn't really dominate the global pattern like a strong one does. It's more like a background influence. So what happens then when that typical main driver isn't really in charge?
Well, it kind of creates a vacuum, you could say. The atmosphere becomes much more volatile. It's open to influence from other drivers, things that might normally be secondary. And the big one this year, the really crucial factor, seems to be happening way up high in the stratosphere. It's all about the state of the polar vortex.
Okay, the polar vortex, that giant spinning mass of cold air high above the pole. What specifically is making it seem so vulnerable this year?
It comes down to something called the quasi-biennial oscillation, the QBO. Now, this is a regular flip-flopping wind pattern way up in the tropical stratosphere, and this winter it's shifting firmly into what we call an easterly phase.
Okay, QBO, easterly phase. We hear those terms, but how does a wind pattern miles up, over the tropics actually end up affecting whether you need a heavier coat?
Right, it seems disconnected. But think of the polar vortex like a spinning top. A westerly QBO tends to let it spin smoothly, keep it strong and tight. The easterly QBO, though, it interferes with energy moving up from the lower atmosphere, these large-scale waves. When those waves hit the easterly winds, they can get deflected or absorbed in a way that disrupts the vortex. It basically makes that spinning top wobble. It destabilizes the whole system.
So if the vortex is already prone to wobbling, that seriously raises the odds of a major disruption. You're talking about a sudden stratospheric warming and SSW.
Exactly. A major SSW becomes much more likely. And these aren't small events. We're talking a rapid warming, sometimes up to 50 degrees Celsius, way up there, like 20 miles high over the pole. That sudden intense heat just shreds the vortex. It can cause it to collapse or split apart or get pushed way off the pole.
And when that happens, when the vortex collapses up there, how long before we actually feel the effects down here at the surface? Is there a delay?
Yeah, there's a lag. That signal, that disruption, it needs time to work its way down through the atmosphere. Typically takes about 1 to 2 weeks. And when it arrives, it often triggers strong, high-pressure blocking patterns, say over Greenland or maybe Alaska. That blocking then basically flings open the Arctic door. It allows that frigid air, normally locked up near the pole, to spill southward into places like North America and Europe too. This combination, the weak La Niña leaving the door open, and the easterly QBO pushing the vortex towards instability, that's the recipe for potentially severe cold outbreaks.
Okay, wait. If the QBO link is so strong, and we know past easterly QBO winters have seen major colds, why does the official NOAA outlook, which is mostly based on that weak La Niña, still show that classic pattern? Warm and dry south, colder, wetter Pacific Northwest.
That's because the official outlook is a 90-day average. It smooths things out. An SSW brings intense, but often relatively brief, cold snaps. Those can get lost in the seasonal average. Plus, there's another piece, an oceanic wildcard. That persistent warm water in the North Pacific, sometimes called the blob. This marine heat wave can act as a ridge amplifier. So if you get high pressure building over the west coast, fueled by that warm water, it forces the jet stream to dive south downstream. That creates a deep, cold trough right over the central and eastern parts of North America. It reinforces the cold potential from any SSW.
So the cold surprise we mentioned isn't about the entire winter being brutally cold everywhere. It's more about the potential for extreme volatility, periods of really intense, maybe even record-breaking cold, possibly masked by milder conditions the rest of the time. And it sounds like the Midwest, the Northeast, maybe parts of Europe are prime targets.
Precisely. It's about high-impact episodic cold. The overall seasonal average might end up near normal or even slightly mild in places, but punctuated by these really significant Arctic plunges. But, and this is key, it really hinges on whether that major SSW actually happens. That's the trigger.
Okay, so for listeners wanting to track this risk as we head into winter, what are the key signposts? What should you watch for?
Right, there are a few things. First, keep an eye on stratospheric temperatures right over the North Pole. We look specifically at the 10 HPA level, that's about 30 kilometers up. Rapid warming there is the direct signal an SSW might be starting.
Okay, stratospheric tense. What's second?
Second is the expansion of snow cover across Eurasia, particularly Siberia, during November. A faster, more extensive snow buildup over there can precondition the atmosphere. It helps build up Siberian high pressure, which can later on send energy upwards to disturb the vortex.
Makes sense. And the third signpost, this would be about confirming the effects are actually reaching down.
Exactly. That's watching the major climate indices, specifically the Arctic Oscillation, the AO, and the North Atlantic Oscillation, the NAO. If you see these indices trending strongly negative and staying there, that's a very strong signal that high pressure blocking has set up. A negative AO means the pressure pattern is favorable for discharging Arctic air southwards. It's like the gate is open.
So it's not just about groundhogs this year. You're watching atmospheric waves, stratospheric temperatures, snow cover in Siberia. It points towards a winter that could be defined by this high-altitude chaos, potentially bringing brief but maybe quite memorable cold snaps. Now you know what to look for.